The sun just gave us the most incredible New Year's gift, and if you're watching this right now, you need to drop everything and pay attention, because tonight could be your chance to witness something absolutely spectacular. Multiple coronal mass ejections are converging on Earth's magnetic field at this very moment, and NOAA has just issued a G2 geomagnetic storm watch for the next 24 hours. But here's what they're not telling you about what's really happening up there. On December 31st, as millions celebrated the countdown to 2026, our sun was putting on its own fireworks display. At 1351 UTC, sunspot region AR4324 unleashed an M7.1 solar flare, one of the most powerful eruptions we've seen in weeks. This wasn't just any flare. The explosion was so intense that it triggered an R2 moderate radio blackout across the entire Atlantic Ocean, disrupting communications for ships and aircraft off the coast of Brazil for over 20 minutes. But that M7.1 flare was just the opening act. The real story is what that flare hurled into space. NASA's SOHO coronagraph captured the resulting coronal mass ejection racing away from the sun at 893 kilometers per second. That's nearly 2 million miles per hour. Type 2 and Type 4 radio emissions confirmed this was a significant Earth-directed event. And here's where it gets interesting. This CME isn't arriving alone. Between December 28th and December 30th, 3 additional coronal mass ejections were launched from active regions on the sun, and all of them are reaching Earth right now, creating what space weather forecasters are calling a CME convergence event. Now, NOAA is predicting a KP index of 6, which translates to a G2 moderate geomagnetic storm. For those of you who've been following solar activity for years, you know what this means. The Aurora oval is going to push far south of its normal position. We're talking about potential aurora visibility across 18 US states, from Alaska all the way down to Illinois, Wisconsin, and northern Michigan. Some models are even suggesting the northern tier of New York could see a glow on the horizon if conditions align perfectly. Think about that for a moment. New York, not Fairbanks, not Tromsø, but locations at 42 degrees north latitude could witness the northern lights tonight. But I want you to consider something that doesn't quite add up. NOAA's forecast models show this CME arriving with a glancing blow, heading northeast of our planet. Yet they're still calling for G2 storm conditions. Why? Because when multiple CMEs arrive in rapid succession, even glancing impacts can produce cumulative effects that exceed what any single eruption would create. It's like ocean waves converging at a harbor entrance. The combined energy creates something far more powerful than the individual components. Progressive scientists who actually study real-time solar wind data are suggesting we might see brief G3 strong storm periods if the interplanetary magnetic field turns strongly southward at just the right moment. NASA's official forecast doesn't mention this possibility. Make of that what you will. Here's what you need to understand about timing. The primary CME from that New Year's Eve M7.1 flare is impacting Earth's magnetosphere right now as you're watching this. Solar wind speeds have already elevated to around 450 kilometers per second, and the interplanetary magnetic field is showing increased turbulence. The critical factor, the one that determines whether we see widespread auroras or just high-latitude displays, is the BZ component of that magnetic field. When BZ turns southward and stays southward for extended periods, that's when Earth's magnetic field opens up like a funnel, allowing solar particles to pour into our upper atmosphere. Current measurements show BZ fluctuating between plus and minus 3 nanoteslas, right on the edge of geo-effective conditions. Now I'm going to tell you something that might surprise you. We're currently in the declining phase of solar cycle 25. The smoothed sunspot number peaked back in October 2024 at one above the predictions that NASA and NOAA made back in 2019, when they forecast a maximum of only 115. They were wrong about the strength of this cycle, and here's why that matters for tonight. Historical data shows that some of the most powerful geomagnetic storms don't occur at solar maximum. They happen during the declining phase, sometimes years after the peak. Solar cycle 23, for example, produced its strongest events in 2003 and 2004, well after its 2001 maximum. We could be entering a period where powerful individual events become more common, even as overall sunspot numbers decline. Let me ask you something. If you're located anywhere from Minnesota to Maine, from Montana to Michigan, are you planning to go outside tonight after midnight local time? Because that's when geomagnetic activity typically peaks. The best viewing will be away from city lights, looking toward the northern horizon. But here's what I want you to think about. We've had multiple aurora watches over the past few months. Some delivered spectacular displays, others fizzled completely. The difference often comes down to factors that even the most sophisticated models can't predict with certainty, more than an hour or two in advance. That southward BZ component I mentioned, it can flip in minutes, turning a quiet night into an aurora explosion or shutting down an active display instantly. There's something else happening that deserves your attention. Sunspot region AR4324, the one that produced that New Year's Eve flare. It hasn't finished yet. This region still maintains a beta-gamma magnetic configuration with a weak delta structure. For those of you familiar with sunspot classification, you know that beta-gamma delta regions are the most likely to produce major flares. AR4324 has already fired off multiple C-class flares in the past 24 hours, and it's rotating into an optimal Earth-facing position. Another significant eruption from this region over the next few days could send additional CMEs our way, extending this geomagnetic storm period well into next week. Now, NOAA's 3-day forecast shows storm conditions easing by January 4th, dropping back to G1 minor levels before settling to quiet conditions by January 5th. But I want you to consider the broader pattern. We've also got a coronal hole high-speed stream rotating into a geo-effective position. These streams of fast solar wind, flowing from gaps in the sun's corona, can sustain elevated geomagnetic activity for days, even without CME impacts. The combination of CME effects plus coronal hole wind could keep conditions unsettled longer than the official forecasts suggest. Progressive space weather analysts who examine the full context of solar wind structures often see patterns that the standard models miss. Here's what I need you to understand about 2026. Despite being in the declining phase of solar cycle 25, multiple forecasters are predicting this could be one of the best years for aurora viewing in over a decade. Some scientists are suggesting we might see a double peak in solar activity, where the sun's northern and southern hemispheres reach maximum activity at different times, extending the period of enhanced flare production. The equinox periods, March and September, historically produce 2 to 3 times more geomagnetic storms than other times of year due to the Russell-McFerrin effect, the orientation of Earth's magnetic field relative to the incoming solar wind stream. If we're still seeing this level of solar activity in March, we could witness some truly exceptional displays. But let's talk about what's not being discussed in the mainstream coverage. That M7.1 flare on December 31st also produced a 10-centimeter radio burst lasting 22 minutes with a peak flux of 550 solar flux units. This indicates significant electromagnetic disruption at radio wavelengths, the kind that can interfere with GPS signals, satellite communications, and sensitive radar systems. The R2 radio blackout was reported, yes, but what about the downstream effects on technology that relies on precise timing signals? High-frequency trading systems, power grid synchronization, aviation navigation systems, they all depend on stable GPS and radio communications. A G2 storm with elevated solar radiation adds another layer of potential disruption that rarely makes the headlines. So here's what I want to know from you, and I want you to leave this in the comments. First, where are you located, and are you planning to watch for auroras tonight? Second, based on what you're seeing in the real-time solar wind data, do you think NOAA's G2 forecast is too conservative, or are they overestimating the impact? Third, and this is the important one, do you believe we're entering an extended period of elevated solar activity that could last through 2026 and beyond? Or is this just a brief uptick before the solar cycle winds down? I'm genuinely curious what those of you who've been tracking solar weather for decades think about this pattern. If you haven't already, make sure you're subscribed and hit that notification bell because this CME convergence event is just the beginning. AR4324 is still active. We've got multiple sunspot regions developing on the eastern limb of the sun, and the configuration of the solar magnetic field suggests we're not done with significant eruptions yet. I'll be monitoring the real-time data and posting updates as conditions evolve. Tonight could be the night you finally see the Aurora Borealis from your own backyard. Don't miss it.